So now going to problem number 33. This is I guess page 2 maybe of the calculator portion. So we have to find all the zeros here in number 33. So let's go ahead and do that. I'm going to use my calculator here. You want the zeros of a function. I'm going to do it the easiest way possible, which is graphing. Now, you may ask, why don't we always do this? And the answer is it doesn't always work. Okay. You'll know if it works, though, based upon like the solutions in the multiple choice. You know, if you have answers that are like the square root of 2, well, that'll show up on your graph, but it'll show up on your graph as a decimal, so it doesn't help you a whole lot unless you know what the square root of 2 is as a decimal. But if your multiple choice are nice rational integer or fraction answers, you can probably just get it from your calculator. And so I've graphed that function, and we're just asking where does it equal 0 at. So it equals 0, it looks like right there where it crosses the x, right there where it crosses the x, and right there where it crosses the x. Think about this equation. It's y equals 2x cubed minus 7x plus 9. So this function, when we graph it, we're just plugging in an x and out comes a y. Plug in an x, out comes a different y. And so all these ordered pairs make this curve. We're just looking for where is it equals 0. Where's the y value 0? It's right at those points. And so I'm going to test them. And the way I test them is on my calculator here. I hit the trace button. And you see once I've hit trace how it's highlighted up down here. And it tells me right now when x is 0, y is 9. That's this point that's blinking up there. If you can see it, I'll erase it now. And so I wanted to find out specific points. Like I think -1 is one of my answers right here. So I'm going to make sure this x is -1. And I do that by just hitting the trace. Hit my trace. And then I just type in -1. And I hit enter. And it'll tell me if I'm correct or not. And you can see how the y value has changed to 0. So yeah, that's one of my solutions. This solution right here, let me circle him. That one's a little bit to tell what he is. It looks like he's between 2 and 3. I could look at my table and I can kind of tell from my table. You can see right here at 3 it equals 0, which I think we already knew. Let's take a look. That was not my eraser. There's my eraser. So I just tested by looking at the table. I found that 3 is the solution. So let's make a list of these. I got -1 I tested the 3. The one between 2 and 3 I haven't found, so I think I'll try the number right between 2 and 3. Try 2, between 1 and 2. So I'll try 1.5. Yep, that gave me a 0 also. So there's my 3 solutions. 1.5. Now, if you don't have a calculator, if you forget how to do it, we can do it by factoring. So if I look at these 3 terms up here, I can not take an x out at all. In fact, I can't factor this. In which case, if I was doing this by hand, you'd have to go with your P over Q list. To make that list of 1 over 1, 1 over 2, 3 over 1, test them using synthetic division till you found one. And as soon as you found one, like -1, you could do the synthetic division with it. Let's see, I bring down the 2, -2, -9, 9, which is 0. Oops, 0 plus 9 is 9. And -1 times 9 is -9. It came out to 0, but the point is, I now know that -1 is a solution, and then you could factor this 2x squared minus 9x plus 9 to find your other solutions. It's going to be 2x and x. To get a 9, I'm thinking a 3 and a 3. This will give me 6x and 3x, and they add up to -9 in the middle. So once I got it factored like that, I can see now the solutions, 3 over 2 and 3 are the other ones. So that's how you crank it out without a calculator. But we have a calculator on this portion, so I don't know why you would do that. Okay, let's look at this next question here, number 34. 34, what is the domain of this? Well, this is a square root function. If I want the domain of a square root function, I just take what's under the radical and say, you have got to be positive. And then I solve it. It tells me the domain. X has to be greater than -3. 35, right away, man, they say graph. And so if you have to graph, you're going to run to your calculator and graph. Okay, so let me shrink this down a little bit. And so on my calculator, I'm just going to type in that function here, clear out my old one. I've got the square root of an x plus 4. I got arrow out of the radical and then plus 5 and zoom 6. Hey, look at that. If we take a look at that graph, I can see it starts right here. Remember, these are like parabolas on their side, and you only get half of it. Okay, the other half we don't get because of square rooting of negatives and not getting negatives out of radicals. The point being, though, if you look at this thing is located right there at -4, 5. And the function, if you look at it, square root of x plus 4 plus 5. Right there's the shift left by 4, and there's the shift up by 5. So we kind of had an idea where it started already. And so I'm putting that on my graph over. Now let's go ahead and get another point. Another good point to get is this Y-intercept right here. And so to get your Y-intercept, we just have to ask our calculator, hey calculator, when x is 0, what's y equal to? So I've cleared my calculator there, and I'm going to wipe away a little bit of this stuff here to keep it a little clean. And so I want to find where it crosses the y-intercept, the y-axis, the y-intercept. And so I'm going to go over to my calculator. I'll hit trace. I'll type in 0 for x. You can see there's a 0, and I hit enter. It tells me, it's 7. So now I know it crosses at 7 right there. This was at 5, so 2 more, 7. Okay, and it also follows the pattern of the square root function. If you remember how the square root function goes, 0 when you square root it gives you 0, 1 gives you 1 when you square root it, and then 4 you use because the square root of 4 is 2. Okay, and so that's this point 0, 0. This is the point 1, 1, and the point 4, 2 we've already graphed. 4 away from where we started and 2 up. We could also do 9 gives you 3, so you could go over 9 and up 3, and you'd get another point. But that's enough right there to say what our graph looks like and to be able to pick it out of a series of graphs where we're choosing multiple choice answers. Okay, let's go ahead and answer 36 now. 36, if I erase a little bit of this garbage up here, so we have a little space here. Let's see here, I'm going to erase some of my answers by accident. I may have to fill those back in. But if I look at my graph right here, I can tell the domain. The domain is the x values. Well, it starts on the x-axis. If I line it up here, this is right here at -4. So that's the lowest x value, and that's where our domain would start, and then it goes to the right forever. That's positive infinity, or x is just greater than or equal to that -4. The range, I can just look at the graph again as well. My range, let's see the smallest y value it starts at. It starts right there when it's 5. And then it goes upward, 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 and to the right. So it's greater than or equal to 5 because we're going up. So there we go, graphing it real quick and easy. All right, now this equation in number 37 is a reference to what's called an exponential function. Okay, exponential functions look like this. A and B are some numbers, and x is your variable just like it always is, but it's in your exponent spot. And any equation of this form, okay, let me write one down for you, like f of x equals, I'm going to use a as 4 because that's what's in our problem, and I'm just going to put some b value in there like 2. Any equation that's in this form falls into two categories. It either follows into this growth category or it falls into the decay. Okay, growth means it gets bigger as x gets bigger. Decay means it gets smaller. Okay, it gets just like you'd think something decays, it gets smaller and smaller and goes away eventually. And whether it's growth or decay all depends on the b value. That's it. Okay, and it looks like this. Basically, if b is bigger than 1, then you're going to have a growth function, and it will look something like this, whereas x gets big, it goes up and up and up and up really fast. And then the other type is a decay problem. And decay problems, the b value is a fraction, some number between 0 and 1. And when you have a situation like that, the function starts big, but as it goes on, it gets really small. So it's called a decay function. It gets smaller and smaller and smaller. Okay, so as long as they just want us to write a function or give a value for b, and so if you had to give a value for b, you could use for growth anything bigger than 1. You could use 1.1, 1.2, you could use 2, you could use 3, you could use 8, you could do 24. It doesn't matter. If you type in a number that is bigger than a 1, and I'm going to show you this on the calculator here, if I can get things situated just how I want them. Let's get in there, tap a little bit, see if they'll do it. So I'm going to graph this guy real quick. Clear him out, and I'm going to go y equals 4. See if I can get some of this stuff out of the way. There we go. That should help a little bit. So I'm putting my 4, maybe. There we go. Parentheses 2, and parentheses to the x power. And I'm going to do another one here. I'm going to do the 4 again, but this time I'm going to put in a fraction. I'm going to put in, 1/3 and raise it to the x value. Okay, now it's going to graph both of these. The first one with the 2, the number bigger than 1, you'll see this growth thing down here. And then the second one will come in. I'll put him in a dark line over here. I might just arrow back if I can. There we go. And I'm going to make him a dark line. There we go. And that'll be the second graph. So I'm going to hit my zoom 6. Here comes the growth one, the 2 for the b value. Here comes the decay one, the 1/3. And you can see how it goes down. Okay? So when you get to that problem, just if you want growth, make sure the number is bigger than 1. If you want decay, make sure it's a fraction that's between 0 and 1. Okay, so here's all the answers you could put. It's infinite number of answers you could choose for a growth function. Same thing for b for a decay function. So b could be a half, it could be a third, it could be 2/3, could be 5/8. Notice nothing can be negative because they don't work. Causes your function to do something strange. It could be, 2/501. Doesn't matter as long as it's a fraction. Okay. Be careful though. Things like 8/3, that's a fraction, but it's not less than 1. So this one would give you growth as well. It's equal to 2 1/3, bigger than 1 clearly. Alrighty, I think that takes care of that side. So let's run through these over here real quick. All right, 38 is a logarithm problem. Now this is a logarithm, log base 2, okay? Our calculator, remember we talked about it yesterday, only does log base 10, so a calculator cannot do this problem without a special formula. But that's all right. All we're going to do is change it from exponent form into log form. So let's review how we do that. Here's our basic one. This is 2 cubed written with an exponent. And then its equivalent logarithm statement is this. Log base 2, remember you keep the base, of 8, and the logarithm tells you the exponent. So that's how we convert from one form, exponent form, into the other form. So I'm going to do that with this equation. Now, it's not equal to anything, so I'm just going to say, hey, u equal x, so I have something to rewrite it as. So my base is 2. I'm looking for the exponent on that 2. That gives me 1/32. And that's all you have to figure out, is what that x is. Now, that x can't be positive, okay, because if you take it 2 to the second power, you get a 4. You don't get 1/32. If you take it to the third, you get 8. You don't get 1/32. But if it's a negative exponent, then it's 1/2, and we can start to see how that 32 could develop with the 2 in the denominator. Now, the way we actually work it is you just leave the side that has the base and the variable on it, and you rewrite the other side as a power of 2 in this case. And if it's not a power of 2, we can't do it this way. But it will be a power of 2, or whatever your base is. If this is a 3, you'll write it as powers of 3. But see, as I slowly work on this left side, I'm just going to recopy that. Give myself a little space here. I'm going to try to work on just the right side. So I'm going to leave this left side. The right side, I'm going to rewrite that as 2 to the negative 5th, because that's just working that exponent law in reverse. And now I can see what x is. Hey, what's this logarithm equal to? X. What's x equal to? -5. This logarithm is -5. Okay? And so you can test certain things on your calculator. Now I'm going to show you a method on your calculator. First of all, I'm going to test that 2 to the -5 power. So let's blow this up. I'm going to clear this out if I can. There we go. And I'm going to just take my 2 and raise it to the -5 power so you can see what that looks like. So there's 2 to the -5. I'll hit enter. I'll hit math fraction. And you can see I get 1/32. Now, real quick, if you want to just learn a quick thing so you can do it all on your calculator, log base 2 of 1/32 can be calculated using base 10, which is what our calculator does, by taking the log, whatever you were working with, over the log of the base. And notice I haven't put little things below it. These are both base 10s, and so it's called the change of base formula because I was base 2 and I've written it as an equivalent base 10 problem. But my calculator does base 10, so I can just type in now log, hit the log button, of 1/32, so 1 divided by 32 in parentheses, divided by the log of 2, and it will spit out a decimal. Oh, it didn't. It actually gave me, because we were just getting -5. So it spits out my final result and says, yeah, that thing's just equal to -5. So there, it cut some corners for us by knowing how to use our calculator. 39, let's graph this thing and let's show some key features here. So I got my calculator. I'm going to go to y equals. Clear that out, clear this one out. And I'm just going to type in 2 parentheses 3 parentheses to the x. And guess what? It's going to be a growth function because it's y equals a times b to the x. We just talked about that one. I'll zoom 6 it. We'll see that growth happen. Okay, I'm going to zoom in here a little bit. Okay, so some key features they say to note. Well, key features are right here. Where does it cross the y-axis? And what line is it getting really close to? Okay, in this case, it gets really close to the x-axis. It never actually touches it. And you actually can kind of see that if you ever look at your table here. It never gets to 0, just gets close. Okay, let's find out where it crosses the y-axis. We've done this before. So I'm just going to do a trace on it. If I can get everything shrunk down again. Plays this little game once in a while. See if we can get in here, hit trace. Hey, thank goodness, because I can't see my numbers, but it's already at, hey, when x is 0, it crosses at 2. So I know my function is going to cross right here at 2. If I want to get some more values for it, I can go second, and I'll choose graph, which is my table. And you can see in my table, I've got plenty of points I can graph. I can see the 0, 2, right there, and I've already plotted that, but I can plot 1, 6, 2, 3, 4, 5, 6, there we go. I can see what happens on the left side here. So what happens when x is, well, I got -1. See how it goes to 0.6 repeating. Then at -2, it's going to get even smaller. I think slowing down a little bit. -2 is 0.2, -3. So it's getting really close to 0 as I go to the left. But notice, even that 9.1 e to the -4th, that's 0.00091. Okay, so it gets really close to the x-axis but never touches it. So I'm going to sketch that graph in. There we go. That's what it looks like. This line it gets close to, you aren't asked about it, but that line you get close to is called an asymptote. That's it. You should be able to pick one out of a lineup when you're given 4 graphs that correspond to whatever your equation is. Last one on this page, number 40 here. You got a polynomial equation with rational coefficients. Solutions are 2 minus root 3. I'm going to make a note of those. Minus 3 root 5. And it has solution for plus 8i. And says, what other solutions does it have? Well, because it's got rational coefficients, it must also have the conjugate of this 2 minus root 5, 3 root 5, so 2 plus, and it must have the conjugate of this imaginary one. So 2 answers for this, those 2 right there. All right, that should solve all of that one. I'm going to write in a few of these answers again, just so you have them. This one came out to -1, 1.5, and 3, I believe. Domain here was greater than -3, and I believe everything else is filled out.